My name is Lennart Elmqvist, and I'm a coordinator for a master program in product development and materials engineering. And I'm going to talk about an approach to foster integrative skills during the engineering. I've done this work together with Glenn Johansson, coordinator for another program in production system. And we come from School of Engineering in Sweden, Jönköping University. So I want to say a few words about Jönköping University first. First, I will say, where is Jönköping? We are here in Copenhagen, and we have Jönköping here. It's about 300 kilometers in that way. Thanks. Jönköping, we have a university, which is based on 4 different schools. International Business School, School of Education and Communication, School of Health Science, and School of Engineering, which is where we come from. School of Engineering has about 2,200 students. We have education all the different levels, bachelor level, master level, and we also have on PhD level. The teaching is given by 5 different departments: civil engineering, lighting design, mechanical engineering, where I come from, industrial engineering and management, where Glenn comes from, and then we have computer and electrical engineering, and physics and mathematics and chemical engineering. So, this is about integration between product development and production management. How the students get involved and start to work together in a collaboration. And that is not easy, because there are many barriers to this. For example, personality, cultural, language, organizational barriers. It can be different departments, as it is in our case. And besides, engineering education programs are often constructed on the basis of domain-specific knowledge. They're constructed to be domain-specific, which is one of the problems. So the idea is to ensure that the students meet each other and start to collaborate already during the education. So when they come to the industry, they have an ability to work cross-disciplinary. And if we give the students this help during the education, it will be much easier for them to take away all these barriers later on. Just a few words about the 2 different programs. This is the program that I'm coordinator for, product development. The aim is to develop skills that are needed to develop and design advanced products. It's based on 3 different research groups about computer-supported engineering design, simulation and optimization, and material manufacturing. I'm not going to go into details in the program plan, but 3 semesters with courses, and then we have a 4th semester with the final thesis project. That is the structure. The second project is production systems. It's about knowledge about industrial systems, competitive production. It's about design and development of these systems, and also how material information should be handled in these systems. And it's also about interaction between technology and humans. Also in this case, we have 4 semesters, where the last one is the final project. So the purpose was to find courses where students from each program could engage in collective activities. And we started this discussion, or started this work, when we were invited to a workshop. There was a workshop that was organized by a Swedish program, the Innovation Engineering, Tshaped. And the workshop was hosted by Stanford University. At this workshop, we learned how to create prototypes. We learned how to prototype. And that was one part of the workshop. And the idea is to develop a physical model which stimulates creativity. So we tried to prototype this idea about these 2 programs and how to collaborate. And here we have the result. I said that it's a physical model, but this is not a physical model that we have here. But this is. here we have this model. We can put it here. It's been crashed in the transportation. Okay, what is this illustrating? First of all, we have 3 different levels. The first level tries to describe the 2 different programs, separated by a wall. Oops. Separated by a wall, illustrating that we have no communication at all between these 2 programs. Of course, it's not a wall in the reality. This is the barriers, all the barriers that I talked about before. I don't know which one you prefer that I point on, but I think you can see the color sticks here. So yellow sticks is a symbol for students on production management, production system. The purple sticks are students from product development and materials engineering. And you can see that they are on each side of the wall without communication. On the next level, we have the program plans. We have 4 semesters like this, and then the different courses in each semester. And during the workshop, we identified 3 possible courses or possible activities that we could, where we could have collaboration for the two programs, between the 2 programs. And they are symbolized by these connections here. And at the bottom, the result is that we, you can't see what it is. It sets teams, because the students get learned to work in team from different disciplines. That is the point, from different disciplines in the team. Learn how to communicate between the different disciplines. And they become what we call T-shaped people. And that's what we have here, T-shaped people. And you can also see the purple and the yellow sticks that are twisted together here now. So now we have a collaboration between the students, and they become T-people. This was a physical model. If we try to translate this to more paper product friendly diagram, we have the different semesters, the 2 programs, and then we have the 3 courses that we identified as suitable for collaboration. So if we start with the first one. In both programs we have an introduction course. When the students come, they first have an introduction course. And we realized that we can actually replace these 2 introduction courses with 1 common instead. And we suggest that it's called industrial product realization, and it's both product development and production related issues. And of course there are many advantages with this, but to give 2 examples, we develop the personal relationships from the beginning, already from the start, which means that it's much easier for these to collaborate in the program, in later courses. Another advantage is that it gives the students a common platform. We know that all the students have the same knowledge about production development and product development, which means that we can more or less give them an equal background from the beginning. Of course, there should be some kind of project in this course. And the idea is that this course prepared for collaborative work during the education in the later courses. The second course is concurrent engineering. We realized when we started to discuss the different courses, 2 programs, we realized that there were 2 courses that actually almost totally. So we suggest that we replace these 2 courses with another course where we have this overlap. And this course should focus on aspects related to concurrent development of products and production systems. And also in this case, there should be a project, so the students really work together, coming from different disciplines. So these projects means that the student from product development, of course, work with product development issues, and the student from production development work with production-related questions, but same project. And then we have the final project, final thesis. The idea is here that we set up projects with students from both the programs in the same project. Of course, they should be examined separately, also and maybe also supervised with two different supervisors. The project in this case be based on a relevant industrial problem, and we also want to have companies in these projects. And this also means that it can be possible to arrange larger projects, and maybe these projects are more attractive to the industry if we can increase the size of the projects. And the idea is that we prepare the students for work for the work later on in the industry. And we actually have also 1/4 course, which is given already now in multicultural competence. It's not about the disciplines, it's not about production, it's not about product development, but it's still a course where the students meet, and that means that if we have these 3 courses plus this multicultural, I think this multicultural competence course will give even more in that case. I mentioned the T-shaped people. If we start with T-shaped people, that means that they have a very good and deep knowledge. This is the I-shaped. T-shaped people with the same knowledge, and that is important. We don't want to take away any knowledge. We don't want to decrease the level. So it must be the same knowledge. But then we have a communication, and that is the T-shaped peoples are supposed to collaborate and solve problems across the disciplines. That is the situation as we have here. And they get qualities that are important, for example, in problem solving, brainstorming, and so on. But it's very important, I have also the same level of knowledge. That is really important. We don't want to take away anything. So, some concluding remarks. The development of physical prototypes clearly helped to induce creativity in the discussion. I felt that it was really good to discuss in this way. It really helped us. And I've never done it. I say that you should try to do this, because it's really fun also at the same time. And we're still using this model. We made it in December 2010, and we still use it when we discuss these problems or questions. So it's really good. The approach presented aims at overcoming potential barriers to collaboration between product development engineers and production management engineers. So we want the students to become cross-disciplinary when they start to work in the industry, and we want to give them the ability to discuss, understand each other, and be able to communicate. And these students are more likely to establish a good understanding for each other, making it easier for them to solve problems together. And we would like to acknowledge Pipe for organizing and financing the workshop, and we also would like to acknowledge Stanford University for hosting the